What is random sampling? If we want to know the coverage in an area with a health service, we could just talk to everyone in the client group, mothers for example, and ask them if they received a particular health service. But this could be incredibly time-consuming and costly. This is called the census approach, and for regular monitoring, it's just not practical. Instead, we use a technique called random sampling. A wonderful thing about random sampling is that by taking just a few people and asking them questions, we can learn about the bigger picture, our overall coverage. The few can describe the whole. Now, let's see how this works. In this bag, there are 50 green marbles and 50 red marbles. In this other bag, there are 80 green marbles and 20 red marbles. Imagine that each of these bags represents all of the mothers with children 12 to 23 months of age in either Supervision Area A or Supervision Area B. The green marbles represent mothers whose child has been vaccinated against measles before their first birthday. The red marbles represent those who have not. Now we want to know the percentage of children that have been vaccinated in these two supervision areas. One way to get the answer would be to count all of the mothers of those children. That is, count all the green and red marbles in the bags. But we don't have the time or money for that. Instead, we can take a random sample of the women from each supervision area. You can take, say, 30 marbles from each bag and count them. Remember, green is good, red is bad. Around 50% of our first sample will be green. That is what we'd expect from the bag with 50 red and 50 green marbles. From the other bag, Supervision Area B, our sample of 30 shows 23 green marbles, or close to 80% green. Again, this is what we'd expect with 80 out of 100 marbles in the bag being green. We've basically the same result without having to count all the marbles. The few represents the whole. And to check, we can count all the marbles from each bag just to make sure. For this to work, it's important that the sample is random. If I'm a data collector and I just visit houses that are close to the road, for example, because it's easier for me, I might be ignoring all of those other people who aren't getting the right medical attention, and I would never know. That's why we make sure that every house on this map has an equal chance of getting picked. And this will give us a much better idea of the real spread.